So today we're going to talk about a few different aspects of fire. We're going to talk about what makes up fire and the origins of it. We're also going to talk about the different classifications of fire. We're also going to go over the different types of flame that's associated with fire. A few other topics that I want to go over today are the heat of combustion versus the combustion efficiency topics of discussion, and then also, last but not least, the dangers of smoke. When talking about fire, we're referencing an emission of energy. And where does that come from? So it's long before my time. It's been described as the fire triangle. It's three different elements that are composed of that within a confined space and the given proper ratios will produce that emission of energy that we all know as fire, which is an emission of heat and light. So the fire triangle, what is that? That's three different things. It's a heat source, it's a supply of fuel, and then a supply of oxygen. Now, in the 1960s, this graduated to having a better understanding as to, well, it not only needs those three things, but it also needs a chemical chain reaction that needs to take place. Now, both the fire triangle and the tetrahedron both agree upon the fact that if you eliminate any one of those factors, whether it be heat, fuel, or the oxygen supply, your fire will cease to exist, and you'll have eliminated the ability for it to have combustion to occur. With that being said, there's different classifications of fire. In the fire world, we've limited it to five classifications. You have your Class A fires, which are your ordinary combustibles, your simple plastics, your papers, your rubbers, your textiles, and things like that. Your Class B fires are your flammable liquid fires. Those are more along the lines of your gasolines, your diesels, and things like that. You also have your Class C fires, which is in reference to your energized electrical equipment. But very simply, as soon as you de-energize it, either turn off the switch or unplug it, it becomes a Class A fire. Then they move into Class D fires. Your Class D fires are your specialized or your combustible metals. More commonly for us in the fire service, those have been known as magnesium and things like that. Those have been used to construct Volkswagen engine blocks. The last one is your cooking oil. That one is somewhat new to the fire service within the last decade or so, but those are your grease fires and things like that that are used in the restaurant business. When talking moving forward as far as the flame, now a flame can be characterized as a premixed flame or it can be characterized as a diffusion flame. First and foremost, we have to discuss what a diffusion actually is. Diffusion is essentially a barrier that cannot be seen by the naked eye to us as human beings, but it happens on a molecular basis based on atoms in higher pressure and lower pressure. Now this happens throughout all aspects of life. It happens within our human body in the process of osmosis or even diffusion in our sodium potassium pumps, but in regards to flame, that barrier is known as your combustion layer or your reaction layer. So you have your fuel-enriched environment, your combustion or your reaction layer, and then your oxygen environment. Now, if we're talking about a diffusion flame, that's something that naturally takes place from the ambient air and the oxygen that's in our ambient air, approximately 21%, that takes place in that combustion layer to our fuel layer. Now, if we think about a candle, the candle wick we're going to reference that as our fuel enriched portion of the candle. From outside of that, you have the combustion layer. And that higher pressure, that fuel enriched area, is trying to equalize naturally so it can reach its homeostasis portion to the oxygen enriched area. Now in the middle, they meet, allowing for combustion to occur. Now that's a little bit different than the premixed flame that I'm going to reference, because the premixed flame essentially, if we think about a welder, he utilizes an oxyacetylene torch. So when he does that, he's got his acetylene and his oxygen pre-mixed prior to striking it with his striker, allowing that ignition source to create his flame. So it's either something that occurs naturally through the ambient air, causing you a diffusion flame, or it's something that's pre-mixed, typically probably more along the lines of a synthetic process that has been man-made, and we're pushing through there, giving us a premixed flame. When we're referencing the heat of combustion versus the combustion efficiency, these are numerical values that scientists have given this whole theoretical process of flame and fire and all that. The heat of combustion is a measurement in kilojoules that is given to a product based on its ability to create energy when it's being oxidized. So simply something that can be sitting out in the environment and essentially off-gassing, it still has molecules, it's still producing energy, just not to the extent that we can see by the naked eye. Combustion efficiency is a numerical value that's given to something that reaches 100% combustion, which theoretically is unreachable, because in an environment you're either going to run out of the fuel or you're going to run out of the oxygen in that atmosphere to continuously give it 100% combustion. So scientists have given it a numerical value from either 0, 100% combustible, or 1, which is a non-combustible product. And then lastly, the dangers of smoke. So the dangers of smoke is huge in the fire service, because if you don't understand your smoke and understand that byproduct of combustion and understand the fact that smoke is unburned fuel, you essentially don't have an essence of time in your head and how much time you have to get to the seat of the fire and make an effective extinguishment. So smoke is essentially a byproduct of combustion, but it's toxic gases, including carbon. Carbon in our environment is what burns. So essentially you have unburned fuel all within that environment, and depending on how much and depending on your oxygen that's within that environment, once it reaches that proper air to fuel mix ratio, you can have a product of combustion that can be detrimental to us as firefighters in the fire service. So understanding that smoke is unburned fuel is huge in the fire service. I hope that this small tutorial video was helpful on the key terms that were asked of me to present, and thank you for your time.